Hi, this is Mrs. Bazin, and in this screencast we're going to talk about the chemical mole. So what the mole is a unit we use in chemistry to describe numbers of atoms. It is very similar to some other units that you've heard of that represent a certain number. So if you say you have 1 dozen eggs, you automatically know that that means you have 12 eggs. If you say you have a pair of socks, that means you have 2 socks. The mole is no different. If we say we have 1 mole of a substance, that means we have 6.02 times 10 to the 23rd units of that substance. So you could say you have a mole of M&Ms. That would mean you have 6.02 times 10 to the 23rd M&Ms. You could have a mole of basketballs. That would mean you have 6.02 times 10 to the 23rd moles of basketballs. So we would never use this unit to describe those types of things because that would be a ridiculous amount of M&Ms or basketballs. But when we use that when we're talking about atoms or molecules, it makes the amounts of those things much more manageable. So 1 mole in chemistry we refer to as 6.02 times 10 to the 23rd atoms or molecules. Now this number we call Avogadros number, and it's named after this guy here, Amadeo Avogadro. He studied volumes of gases and their relationship to the relationship between the numbers of moles of gas and its volume. So they honored him by calling this 6.02 times 10 to the 23rd Avogadros number. So that's what we refer to it as in chemistry. Another term that we need to look at is something called molar mass. Molar mass is the mass in grams of 1 mole of that substance. So if we have 1 mole of a substance, we know we have 6.02 times 10 to the 23rd atoms or molecules, but we can also say 1 mole of a substance is equal to its molar mass. So we get a substance's molar mass by looking at the periodic table. So if it's just an atom by itself, then molar mass is equal to whatever number is in the average atomic mass of that substance. If we have a compound, then we just add up all of the elements in that particular compound. So again, we see 6.02 times 10 to the 23rd equals 1 mole, which is equal to its molar mass. The reason this is important is because we can then use this as a conversion factor. When we're talking about amounts of substances in a lab, we might be given the numbers of molecules or the numbers of atoms or the numbers of moles, but in our lab we can't measure. We don't have a piece of equipment that measures atoms or moles or molecules. We do have pieces of equipment that will measure grams. So a lot of times we need to convert between atoms and molecules and moles to grams. So here's a chart that just kind of shows a comparison between all these things we just talked about. So over here, if we start with, we have the one in the middle, we have 1 mole of aluminum. We see on the left that's equal to 6.02 times 10 to the 23rd atoms. On the other side, we see that that's also equal to 26.98 grams. If you look on the periodic table and you look at aluminum and you look at its atomic mass, you will see 26.98 in the box. Our next example, 1 mole of gold, again equal to 6.02 times 10 to the 23rd atoms of gold, also equal to 196.97 grams. And again, this last column is the molar mass of all these substances. Our next example, 1 mole of H2, also equal to 6.02 times 10 to the 23rd. This time, its molar mass is 2.02 grams. So all we did to get that was we took the molar mass of 1H multiplied by 2 because there's 2 of them, and that's where we got our 2.02 grams. Last example, 1 mole of water. Again, because 1 mole of any substance is equal to 6.02 times 10 to the 23rd. That's how many molecules we have. And then on the other side, it's also equal to 18.02 grams. And again, we got that by taking 2 H's plus 1 O. And we'll look at some examples of that in just a second. Okay, so here's an example problem. What we're asked to do here is to calculate the molar mass of sulfur dioxide, SO2, which is a gas produced when we burn sulfur-containing fuels. So the easiest way to do this is to look at our formula. So SO2 is our formula. So to get our molar mass, what I'm going to do is write down what elements I have present in that compound. So I have 1 S and I have 2 O's. And that comes from my formula over here. So it's S1O2. Then I'm going to multiply each of those by their mass from the periodic table. So if I look up sulfur on the periodic table, sulfur has a mass of 32.07 grams. Oxygen, if I look that up on the periodic table, has a mass of 16 grams. So 1 times 32.07 is 32.07. And then 2 times 16 is 32. So I add those together to get my total. So I have 64.07 grams. And sometimes you'll see this as written as grams per 1 mole. So my molar mass of SO2 is 64.07. Okay, another example, and I would do this as a practice problem, so I would pause the video for a minute, see if you can come up with the correct molar mass for this, and then come back and check. Okay, so for this one, we have polyvinyl chloride, which is PVC. I'm sure you've heard that term before. That's used for plastic pipes, floor coverings, those types of things. The formula for PVC is C2H3Cl. So we're looking for the molar mass of this substance. So I'm going to make a list of all my elements. So I have C, H, and Cl. Count up how many of each I have. So I have 2 C's, 3 H's, 1 Cl. And I'm going to multiply by their mass from the periodic table. So carbon is 12.01, hydrogen 1.01, chlorine 35.45. So I'm going to go ahead and do my calculation here. So I have 24.02, 3.03, 35.45. So when I add all those together, and again, these are all grams, when I add all these together, I end up with 62.50 grams. So then this number here would be my molar mass of PVC.